This was found in the clouds of Venus, while the traces of the gas was first reported in 2020.
We now realize that the surface temperature of Venus is 900 degrees Fahrenheit.
Roscosmos, in a statement, said the enormous gap between the Soviet Union and its competitors in the investigation of Venus contributed to the fact that the United States called Venus a Soviet planet.
It has been nearly 3 decades since NASA's Magellan mission concluded its orbit around Venus, representing the most recent endeavour to explore this captivating celestial body. Despite the substantial progress made in our understanding of Venus during this period, numerous enigmas persist, continuing to puzzle scientific minds. However, a recent revelation in the form of declassified photographs has illuminated fresh insights into this enigmatic planet. Yes, you heard it right. These images offer an exceptional view of Venus. The origin of these remarkable photographs traces back to the archives of the Soviet Union, captured many years ago, yet intentionally concealed from public scrutiny until now. What revelations do these images hold? Could they potentially challenge our existing understanding of Venus? Let's find out. In the aftermath of World War II in 1946, escalating tensions emerged between two victorious nations, the United States and the Soviet Union. The root cause of this tension lay in the clash of opposing political ideologies, communism and capitalism. This ideological rivalry came to be known as the Cold War. The term cold in this context signified the absence of direct armed conflict between the two superpowers. However, they each supported and fueled numerous proxy conflicts worldwide. This era of geopolitical rivalry endured until 1991, when the Soviet Union eventually dissolved. The space race emerged as a pivotal facet of the Cold War, as both the United States and the Soviet Union vied to demonstrate their technological and intellectual supremacy by achieving the milestone of sending a human into space. Throughout its course, the world was enthralled by this intense competition for supremacy. The contest between these superpowers spurred remarkable advancements in space technology. They launched astronauts into orbit, deployed satellites, and embarked on lunar and interplanetary exploration. The Soviet Union, with its ambitious space program, aspired to transcend Earth's atmosphere and accomplish astonishing feats. Their groundbreaking achievements, exemplified by the launch of Sputnik, the inaugural artificial satellite, astounded and inspired people globally. While NASA relentlessly delved into the mysteries of planets like Mars and Jupiter, the Soviet Union concentrated its efforts on a different celestial body, Venus. In a significant milestone, the Soviet Union achieved the historic feat of successfully landing a spacecraft on Venus in 1970. The mission, known as Venera 7, stood as a remarkable accomplishment due to Venus's incredibly hostile nature, despite its similarity in size and mass to Earth. The challenges commenced with Venus's extreme atmospheric pressure, which surpassed Earth's by a staggering factor of 92. This pressure is akin to being submerged nearly a kilometre deep in Earth's oceans. Additionally, the planet's scorching conditions are striking. Its atmosphere consists mainly of carbon dioxide mingled with traces of sulfuric acid and other gases. Venus experiences a runaway greenhouse effect, resulting in retention of heat and earning it the status of the hottest planet in our solar system. With an average surface temperature reaching a blistering 460 degrees Celsius, it's even hotter than the melting point of lead. Interestingly, Venus possesses a strong magnetic field that safeguards it against the ceaseless barrage of solar wind. This phenomenon gives rise to dramatic electrical storms and dazzling celestial lightning displays. The combination of these cosmic factors makes Venus a highly daunting realm to explore. Notwithstanding these obstacles, the Soviet Union remained resolute in its pursuit of space exploration. Venus provided the ideal hurdle to overcome, serving as a test bed to demonstrate its supremacy in space travel. This determination led to an impressive series of Venera missions, all aimed at unraveling the mysteries surrounding Venus. The ambitious project to investigate Venus began in 1961 with the launch of Venera 1, the Soviet Union's first mission in this series. Unfortunately, it missed its intended target and soared a long way past Venus. Undaunted by this setback, The Soviet Union persisted, launching Venera 2 the following year, but it too failed to reach Venus. However, the saying "third time's a charm" proved true when Venera 3 launched in 1965. Although it crashed rather than landing smoothly, it sent crucial data back to Earth for a short time before succumbing to Venus's severe environment. This encounter was a watershed moment in the Soviet Union's approach to Venus missions. They recognized the necessity for spacecraft improvements in order to collect significant data. The spacecraft was redesigned to be sturdier, and a detachable pod known as a descent module was added. These modules had advanced instrumentation such as barometers, radar altimeters, gas analyzers, and thermometers. The purpose was to acquire as much data as possible during the descent module's limited time on Venus's surface. Venera 4 then provided valuable data during its descent through Venus's dense atmosphere on October 18, 1967. The findings revealed the absence of a global magnetic field and confirmed high levels of carbon dioxide as anticipated. Regrettably, it succumbed to Venus's extreme surface conditions shortly after. In January 1969, Venera 5 and Venera 6 emerged, each sharing an identical design and debuting just 5 days apart. As these spacecrafts plunged into Venus's atmosphere, they collected precise measurements of temperature, pressure, and composition. Venera 7's descent module exhibited significant advancements, aiming for a controlled landing on Venus. Engineered to endure the harsh surface conditions, the mission was launched on August 17, 1970, and experienced relative success. The lander made contact with the surface on December 15, 1970, although it required approximately half an hour of freefall before landing at a speed of around 38 miles per hour. Despite initial doubts about its success, Venera 7 eventually transmitted usable data. It revealed a scorching surface temperature exceeding 900 degrees Fahrenheit, akin to a brick pizza oven's heat. While the probe's pressure sensor malfunctioned during descent, scientists extrapolated data to estimate a surface pressure of about 92 bars, equivalent to depths exceeding a half a mile below the ocean's surface. Venera 8 followed a similar landing on Venus on July 22, 1972, without toppling over, and showcased the capability of future cameras to capture Venusian views despite the challenging atmosphere. It utilized measurements of ambient light levels to achieve this feat. Among the Soviet missions to Venus, Venera 9 through Venera 12, each weighing more than 11,000 pounds, garnered significant attention. Their landers were equipped with cameras designed to directly capture images of the surface. Operational between 1975 and 1978, some cameras encountered difficulties, often due to lens cover issues. Nevertheless, a few managed to transmit the first ever images from the surface of Venus, our solar system's second planet. The initial images from Venera 9 and Venera 10 possess an eerie quality, sharp, detailed, and slightly distorted due to their wide-angle lenses. These images depict an otherworldly rocky landscape that stretches into the distance. Venera 15 and 16, weighing more than 9,000 pounds, lacked landers, but featured cutting-edge radar-based imaging technology. Operating from elliptical orbits, these probes conducted comprehensive surveys of the entire planet from a safe distance. The detailed photographs they transmitted showcased extensive regions of Venus's rugged terrain, revealing image craters, towering peaks, and lava-filled basins. However, among the Soviet Union's notable accomplishments in space exploration, the Venera 13 mission stands out prominently. This pioneering endeavour achieved a successful landing on Venus in 1982, marking a significant milestone. The mission's probe was equipped with a groundbreaking camera capable of capturing 4 colour images of the Venusian environment. This feat was achieved through the ingenious use of a rotating mirror and a filter wheel. These images held a historic distinction as the first instance of colour photography on a celestial body beyond Earth. The photographs revealed a barren landscape characterized by rocky terrain and soil, conspicuously devoid of any signs of vegetation. The scene's predominant hue was a yellowish-orange tint, a consequence of the planet's thick atmosphere. Beyond imagery, the probe collected vital data, including air and ground temperatures, pressure, wind speed, and chemical composition. Notably, traces of organic molecules were detected, sparking intrigue about the potential existence of past life on Venus. Despite its remarkable achievements, the Soviet government never shared the mission's photographs with the international scientific community. These images were treated as state secrets, reflecting the government's determination to maintain its competitive edge in the intense space race against the United States. However, recently, Michio Kaku shared declassified photographs of Venus that captivated the interest of space enthusiasts. Through his insights, Kaku highlighted intriguing details within these images, shedding light on the enigmatic planet and encouraging further exploration. One of the most striking revelations was the presence of extensive volcanic activity on Venus, evidenced by lava flows and craters. These visual features provided a glimpse into the planet's past, hinting at its dynamic geological history. Additionally, signs of water erosion, including smoothed rocks and carved channels, were equally pronounced on Venus. This finding sparked discussions about the planet's historical climate and the potential existence of liquid water on its surface. The images unveiled a diverse mineral composition evident in the range of rock colors and textures, suggesting a complex geology warranting deeper investigation. Kaku's observations extended to the resemblance of certain Venusian rocks to those found on Earth and Mars. This similarity ignited speculation about shared planetary origins or interconnected evolutionary paths that had not been previously considered. Despite these revelations, mysteries lingered about Venus. Notably, the interplay between bright areas and dark regions suggested intriguing possibilities of biological or geological processes, presenting a compelling enigma deserving of further scrutiny. So, what lies ahead in the realm of Venus exploration? NASA's upcoming Da Vinci mission is poised to take the stage, with a projected probe touchdown slated for 2031. This mission primarily aims to delve into atmospheric conditions, though there's a possibility of garnering valuable surface data during its descent. Subsequently, both NASA's Veritas and ESA's Envision missions are set to follow suit, embarking on orbital observations of Venus in the 2030s. Now, we'd love to hear your insights on these developments. Feel free to share your thoughts in the comments below, and if you enjoyed this video, remember to give it a thumbs up and subscribe to our channel. Thanks for watching.